Alright, so we're going to talk about confidence intervals for a difference in means. And we're going to go over some things that we need to understand to get this confidence intervals, but it's a little bit different than what we dealt with proportions. You do a couple different calculations and formulas set up, okay? As well as there's one big part in our conditions that's different as well. So let's go over this. So again, we're going to talk about, so make sure we understand our shape, center, and spread. So again, for our shape, to determine if it is normal and we're good, we're going to check to make sure the population is normal. All right, so our population is normal. And then as well as that your sample size is greater than or equal to 30. So our central limit theorem is met. Again, if it is not, then you need to draw the data out and ensure that there is no strong skew or outliers. Okay? Now, also, when we're talking about our center, which we talked about, our center, again, when we're dealing with this, we have the sample, or our mean of our sample x bar 1 minus x bar 2, so our first and second samples, and in which case that is going to simply be the overall population mean of our first sample, or of our first population, I should say, minus our second population mean. Apologize, got a little tongue tied there. So your first population mean minus your second population mean is giving you your center value overall. And then for the spread, for your standard deviation, all right, looking at of your x bar, x1 bar minus your x2 bar. Okay, and we're going to simply say that that is a square root, and then we need to add the standard deviations for both those samples and underneath that square root. So we're going to take the standard deviation of the first population divided by sample size, the first population, plus standard deviation of the second population squared divided by the second sample size. And that will give us our standard deviation for the difference in means for this. Now, moving forward with the next part we need to talk about, really understanding this, dealing with a confidence interval, right? We need to check off our conditions in our plan part, right? So if we're looking at our plan part, under our state plan, do and conclude, what's the first thing we do? We need to name our tests that we're doing, right? So, or name our plan, if you want to label it that way. In this case, because we have two samples, we're doing a two sample, and because we're dealing with means, it's a t interval for the difference in means. So for your mu1 minus your mu2. So again, two sample t interval for the difference in means. We use a t because we're dealing with means, which is different from dealing with proportions. Proportions, we did a two sample z interval for a difference in proportions. For the means, we're doing a two sample t interval for a difference in means. For the conditions, it's pretty similar to what we've had to deal with, right? Your conditions, again, you need to make sure you have a random sample, right? Random sample. You got your 10% condition met, and you checked off your central limit theorem to make sure that the population is greater than 30, or there is no strong skew or outliers, as well as the population is normal. What we talked about right over here, dealing with your shape. So you gotta make sure your shape is approximately normal, okay? Now, the next big thing is when we're talking about specifics of calculating for our actual confidence interval, right? We're dealing with the do part, and dealing with your specific formula. Then we're going to talk about how we calculate our interval. In which case, the overall base equation, of course, our point estimate plus or minus our margin of error. Well, in this case, your margin of error is going to be your t star times your standard error of your sample difference, right? So with this one, we're going to write this out. Your point estimate is simply going to be the difference, the overall statistic that you get for the difference in sample means, all right? That's going to be then plus or minus your t star, because that's going to take in the effect of whether or not you're dealing with a 95% confidence interval, a 90%, 80%, whatever the case may be, times your standard error, which is going to be the standard deviation that we just dealt with over here for our spread, okay? So we're taking that equation again. Standard deviation of the first population squared divided by sample size of the first group plus the standard deviation of the second population squared over the second sample size. That will give you your confidence interval. Now with this as well, to get your t star, again, let's not forget to calculate that you need to find out your degrees freedom, which is n minus 1. So to calculate your t-star, again, you know your degrees freedom based off of, t-star is based off of not only your confidence interval that you're looking for, but also degrees freedom. It's where you can find the area and degrees freedom to calculate your t-star value, or by knowing those two values, you can look at the table to calculate your t-star value. All right, so let's look at an example and see how this plays out with finding the confidence interval or a difference in means.
Hey, this is Jason Molesky. In this example, let's construct a confidence interval for the difference between two population means. The Wade Tract Preserve in Georgia is an old-growth forest of longleaf pines that has survived in a relatively undisturbed state for hundreds of years. One question of interest to foresters who study the area is, how do the sizes of longleaf pine trees in the northern and southern halves of the forest compare? To find out, researchers took random samples of 30 trees from each half and measured the diameter at breast height, dBH, in centimeters. Comparative box plots of the data and summary statistics for Minitab are shown below. So here we have our box and whisker plot for the northern region and the box plot for the southern region. And we also have our descriptive statistics showing random samples of size 30 for the north and south with their respective means and standard deviations. Based on the graph and numerical summaries, write a few sentences comparing the sizes of longleaf pine trees in the two halves of the forest. Well, the distribution of dBH measurements in the northern sample is skewed to the right, as evidenced by the box plot, while the distribution of dBH measurements in the southern sample is skewed to the left. It appears that trees in the southern half of the forest have larger diameters. The mean and median dBH for the southern sample are both much larger than the corresponding measures of center for the northern sample. Further, the box plots show that more than 75% of the southern trees have diameters that are above the northern sample's median. There's more variability in the diameters of the northern longleaf pines, as we can see from the larger range, IQR, and standard deviation for this sample, and no outliers are present in either sample. Now in this example, notice that we were explicit in comparing the northern portion to the southern portion for every characteristic that we talked about. If you're asked to compare two different distributions on the AP Stats exam, make sure you use explicit words linking one distribution to the other, saying one is greater than or less than, one is more skewed or less skewed, and so on. Don't just list out characteristics for each different distribution. Now let's construct and interpret a 90% confidence interval for the difference in the mean dBH of longleaf pines in the northern and southern halves of the Wade Tract Preserve. Our parameters of interest are mu1, the true mean dBH of all trees in the southern half, and mu2, the true mean dBH of all trees in the northern half of the forest. We want to estimate the difference mu1 minus mu2 at a 90% confidence level. Well, if our conditions are met, we'll construct a two-sample t-interval for the difference in means. We note that the data came from independent random samples of 30 trees each from the northern and southern halves of the forest, so our random condition is met. Because we're sampling without replacement, we have to check our 10% condition. We need at least 300 trees in each half of the forest, and I'd say that's pretty safe to assume. And the box plots here give us reason to believe that the population distributions of DBH measurements may not be normal due to the skewness in the box plots. However, because both sample sizes are at least 30, we're safe using T procedures. We'll use the more conservative degrees of freedom, the smaller of n1 minus 1 and n2 minus 1, or in this case 29. For a 90% confidence level, the critical value from table B for 29 degrees of freedom would be T star equals 1.699. So a 90% confidence interval for the difference in our means will be the difference in the sample means, plus and minus our critical T times the standard error of the difference of those means. 34.53 minus 23.70 from our output, plus or minus 1.699 times the standard error. We have 10.83 plus and minus 7 for a confidence interval from 3.83 to 17.83. Now the calculator's 2-samp T interval gives a slightly different range. In this case, we use degrees of freedom 55.728, and you'll see we have slightly different values for our minimum and maximum, however fairly close. So we can state we're 90% confident that the interval from 3.9362 to 17.724 centimeters captures the difference in the actual mean DBH of the southern trees and the actual mean DBH of the northern trees.
Alright guys, so hopefully that explained more about the confidence intervals for a difference in means and understanding how to determine your shape, center, and spread. In which case also being able to label your plan for the 2-sample T interval for a difference in means. Understand your conditions to have a random sample, 10% condition is met, as well as your central limit throughout. Your sample size is greater than 30. And then going on to the specific do part as far as calculating your interval overall. The key part is definitely determining not only your standard deviation for difference in means, but your T star, in which case you need to worry about your area based off your confidence level, as well as your degrees freedom. All right, so we learned a little something, and I'll see you next time.